Okay, then let's start the session. Welcome to Operation and Planning of Power Distribution System course. This is the ninth tutorial session. Who is instructor Professor Sanjeev Ganguly sir from IIT Guwahati, and I am Satya, a PRF research scholar at the Department of Energy Science Engineering, IIT Bombay. So in this tutorial session, we will see few of the problems related to current assignment which is pending, some economic terms, economic planning, and also some of the aspect regarding discounted rate, present value, future value. So I give the concept of the basic terminology which will help you to solve the current assignment. Okay. So without wasting time, let's start the first. See the first problem. So this is a first problem which in front of you. So here it is given that a utility and set aside the this certain amount which is the today's value today's value for a capacitor bank upgrade needed for after 5 years. So and the discount rate is given what is the equivalent future amount. So you if you know the concept, just try to solve it, and after that I will give the proper framing that what is the meaning of present value, what is the meaning of future value, what is discounted rate, and everything I will explain. Okay, just go through the problem. If you know the answer, just try to solve. After that I will give the solution. Okay, try to solve. I will also solve with you, so take your time and try to think over it. Okay, let me take the calculator. Give me 1 minute. Okay, last 20 seconds. After that, I will give the solution. Okay, I got one answer at option B. Okay, let's see the solution. Okay, so there is a few of the concept we have to understand in this regarding the present value terminologies. Present value, future value, and discount rate, inflation rate. Okay, so this is the thumb rule to understand that. Suppose this is the zeroth year. Okay, and you have a certain amount of money. Suppose x rupees you have. Okay, after 1 year, after 1 year of time, after first year, means ki, when the 1 year passed by, this value, okay, this value will be something else, okay. So suppose if you are thinking in the way that ki, if you are having a y rupees of money, okay, will have at a first year, okay, this y rupees will not be equal to the x rupees, okay, because there is a percent terminology known as the discount rate, because at a present, at present your value of money, your value of money is higher as compared to first year, okay. So as when you are standing here, when you are standing here, okay, and you see that ki after 1 year your present value of the money will drop down, okay. So x rupees if you have, so it will become after 1 year it will get discounted by 1 by d, okay. Just remember this, okay. So when you move to the second year, okay, so at the first year, the money became x divided by 1 by d. D is the discount factor. Okay. So when you see after the first year, because it was already x by 1 upon d, so it was x by 1 by d. So it will become 1 by d again discounted. What it will become x divided by 1 plus d of square. Okay. So this is the money which you are having the second year, okay. So when you move forward, suppose I move to the third year here, okay. So again it will drop down. What it will become, x divided by 1 by q, okay. So in the first, in the zeroth year, if you have the money of x rupees, the first year it will be, its value will decrease, it will become 1 x divided by 1 by d. In the second year its value become 1 by d of square. In the third year or nth year it will become x divided by 1 plus d power n, okay. So just remember this ki your present value of the money will be higher as compared to the subsequent years. Okay, it will reduce as compared to the further year. Okay. Now its important point is that ki the what the question is being telling. Okay, important point to solve. Okay, let me erase this. Okay, just remember this concept what I have told, that your present value of the money will be higher as compared to the subsequent year. Okay, it will get reduced year by year, its value, its worth. Okay. So in this problem it is saying, if you are having, suppose this is the value p, okay. There is a p value at a can set aside today for a capacitor bank upgrade needed after 5 years if the discount rate is 9%. What is the equivalent future amount? Okay. So it is asking that, suppose you having a p rupees p, okay, at the today, okay, after fifth year, suppose this is the fifth year, okay, what will be its worth, okay, it's a, what will be its future value and equivalent future value it is asking, okay. Suppose let's say that ki this p is the present value, okay, we already know this is the present value, okay. Let's assume that it will become rupees q, okay. Subsequently rupees p equivalent future amount is q, okay. So it means that p is equal to q divided by 1 plus d to the power 5, okay. Because what I have told that the present value of the money will become after fifth year. Suppose the fifth year, if you are having the q value, so it will become a q divided by 1 plus d to the power 5, okay. So at the that fifth year the q value will decrease, okay. So what will become the q in the future? What will be the q value? It will be p divided by 1 plus d to the power 5, okay. Or you can remember that future value is equal to present value 1 plus d to the power 5. Okay, what is the present value? It is 7 into 10 to the power 5 multiplied by 1 plus d to the power d. What is d? 0.09 to the power 5. Okay, so this amount will become the what is the future value. Let's understand again. Okay, so it is asking that what is the present value is already given here. The present value, okay, here the present value is already given, that is 7 into 10 to the power 5. Discount rate is given, t is equal to t to the power 5. And here also a statement, in the statement it is given that what is the equivalent future amount. Equivalent future amount, so that's why we have considered q amount. So p will become q. Okay, so the present value is equal to future value divided by 1 plus d to the power n. Here future value then will become present value 1 plus d to the power n. Okay, what is the present value? Present value is already given, 7 into 10 to the power 5. Discount 1 plus 0.09 power 5. Okay, it will become 10 means 10 lakh 77,037 rupees. Okay, so option B is correct. Okay, just remember this concept, that what is the difference between the what is the present worth of a particular money. Okay, it will be higher as compared to the fifth year when you see. Okay, so the present value is always higher. Okay, let's move further, try to solve this with the same concept I have given. Okay, okay, option A, I got one answer. Just use the same concept. Okay, if you're not able to understand, just try once with the same concept I give. After that I will already give the solution. Okay, okay, option A, fine. Let's wait for a few more seconds. After that I will give the solution.
कल सुबह करना है बाकी का मैं बता
Okay, let me give the solution for this. So I have got few of the answers. There option A, option A, option A. It's good that you guys are trying. So let's understand first the problem again with the same concept. So it is like some present future value is already given because it is not a present value. Okay, it is asking that future augmentation costing rupees 18 lakhs will be required after 4 years. Okay, at a discount rate, what is the present worth? Okay, so we have seen that suppose this is a present value of this particular money. Okay, then after fourth year its value will reduce. Okay, it will reduce because suppose this amount is 18 into 10 to the power 5. Okay, so its worth will be reduced, required will be lower than that. Okay, so suppose the present value is x amount, so it will get discounted at a fourth year. How much discount? So it will become x divided by 1 plus d to the power 4. Okay, which is equal to, when you see here, it will get discounted at a rate of this x divided by 1 plus d to the power 4. Okay, an important point to understand that this 18 into 10 to the power 4 is a augmented costing required for a fourth year. So okay, so when you see here, the 18 into 10 to the power 4 is actually the required value which is there at a fourth year. Okay, so it is not like that ki this is required at a this present value. Okay, so it basically 18 into 10 to the power 5 value like here. Okay, what will be the present value of it? It will be lower than that. How much lower? It will be 18 into 10 power 5 divided by 1 plus d to the power 4. Let me explain again. So you are having a future value of 18 into 10 to the power 5, what it is being there in the question. Okay, and it is saying what will be its a present value. Okay, so in the 18 into 10 to the power 4, when you see here, so when you come out to be present value. Okay, so how much it will become? It will become 10 to the power 1 plus d to the power 4 at that duration of time. Okay, after fourth year. Okay, so that's why whatever amount you are having, what is the present value it is required of that accumulated after the fourth year. Okay, it will get discounted and it will become the this 1 plus d to the power 4. Okay, so it will become 12 lakh 29,424. Okay, so always remember that when you're having the a certain amount. Okay, suppose you are having a certain amount at a present, so after few years it will, its value will get reduced. Okay, so what was the correct answer? It was 12 lakh 29,000. Okay, option A is correct. So its value will going to decrease. Okay, suppose the y it is there, so y is basically the certain amount what it became, but it will get discounted after certain year 1 plus d power n. Suppose nth year is there. Okay, so always remember that what is the present value, what is the future value, how much, from where in it is asking, whether it is asking from the outside in, means ki, at a certain duration at particular year time frame, or it is asking for the present value of terms. Okay, let's move further, try to solve this. It is easy problem, but it is asking that what is discount rate. Okay, option B, I got one answer. Let's wait for a few more seconds. After that, I will give the solution. Okay, let me give the solution. Okay, uh, those who are trying, just listen here. So let's. I think you are getting confused on few of the statements. Let me explain further. Okay, suppose I am standing here. Okay, option A. Suppose I am standing at this point. This is the zeroth year. Okay, listen here again. So it's a very important that you can expect one problem on this. Okay, just listen here. And I move to the first year here. Okay, here the 5 year is being considered. So I'm considering this is the second year and this is the third year. Okay, this is the fourth year. Okay, and this is the fifth. Okay, so when you understand that when you were at a zeroth year, so there was a certain amount which was the it's a present worth. Okay, present worth. Okay, but when you move to the first year, its value got reduced. Okay, and it became the x divided by 1 plus d, which I have said. Okay, and this is the present value of first year. Okay, in the statement when you see has a present worth of 16.16 lakh 40,000, which got reduced after fifth year. Okay, so it is saying at the fifth year what was its present worth, it was reduced amount. Okay, and the same when you move to here. Okay, so it will become x divided by 1 plus d of square. Okay, and the further move to here, the x divided by 1 plus d power 3. Similarly, when you move to the fourth year, its worth will become x to the power d to the power 4. Similarly, x divided by 1 plus d to the power 5. Okay, getting my sense. Okay, so it's directly when you wanted to move here the fifth year, it will be x divided by 1 plus d to the power 5. Okay, you just have to discount it. Okay, and when you see here this value, this is the present value at fifth year. Okay, and what is this is the present value at zeroth year. Okay, you have to understand both values are not equal. Okay, so it was x during the zeroth year and it became the x divided by 1 plus d to the power 5, and at that particular of year that is its present rate, present value. Okay, so what in the problem it is saying substation expense of 25,000 after fifth year has a present value of this. Okay, it means that at a zeroth year its valuation was 25 into 10 to the power 5, whose value got reduced at a fifth year. It became 16 into uh, or you can say that 16.4, 16.4 into 10 to the power 5. Okay, So what is the formula here I will use? It will be simply 16.4 into 10 to the power 5, okay, is equal to what was the present worth? It was 20 into 10 to the power 5 divided by 1 plus d to the power 5. Okay, we will cancel it out. 1 plus d to the power 5 will become 25 divided by 16.4. Okay, when you solve it, it will come out to be 8.80. Okay, so option B is actually correct. Okay, option B is actually correct. 8.8. Okay, so you just have to see that, okay, what is the present worth and what will be this future worth. Just with this time frame, you will able to understand. Okay, let's move further. Try to solve this. So this is a statement based, a formula based problem that I will give the solution. You don't need to solve. Okay, just remember that the present worth is equal to 1 upon 1 plus d. Okay, so this is the formula. P is equal to 1 divided by 1 plus d. That is correct. That option, I think A is correct. Option A is correct. So a present worth is equal to 1 upon 1 plus d. Okay, uh, per year it is asking. So it's became the, for 1 year it is 1 plus 1, 1 upon 1 plus d. Why it is saying that? Suppose this was the present value at 0th year. Okay, suppose this is the nth year, so it having a present value something at a nth year. Okay, suppose I assume that x valuation was there at a 0th year and y valuation at a nth year. Okay, when you compare both, when you compare both, so this this y value worth is lower than the x. Okay, because it got discounted. How much it got discounted? It got discounted. X is equal to yth amount divided by sorry, y is equal to basically x divided by 1 plus d to the power n. Okay, that's why when you see what is the its present worth. Okay, when you see that what is its present worth, present worth is basically y is equal to present worth multiplied by x. Okay, because this was the value which is telling that what will be its worth at a particular this point. Okay, because what will be its worth here, it will be lower than this. How much it will be? It will be x plus x divided by 1 plus d to the power n. Okay, getting my point? So yth amount, or sorry, y divided by 1 plus d to the power n. Okay, getting my point? So its worth basically it is lower than that. Okay, so always remember that whatever the y amount which was there at the worth at a nth year, it will just multiply by its present worth multiplied by x. Okay, just remember like this: present worth is equal to 1 upon 1 plus d to the power n. Okay, whatever the factor you are multiplying to get the that value at a particular present value in terms, so it's basically 1 upon 1 plus d to the power n. Okay, here for 1 year it is asking, just replace n is equal to 1. 1 divided by 1 plus 0.12, you will get the 0.8929. Okay, okay, let's move further. Try to solve this. Okay, option C. It's just a formula base, so it's option C is correct. Okay. Phew. Okay, getting my point. So let's move further, try to solve this. This is a very important problem in terms of what will be the strategy or kind of be so let me explain first. After that, just try by yourself. After that, I will give the solution. Okay, you know the EMI options that suppose you wanted to buy a certain equipment but you don't have amount lump sum amount which is required to buy that, and you convert that into the EMI format, and month wise you are actually spending a certain amount which is lower than the actual amount each month. Okay, so what is the EMI basically? It's a equivalent monthly installments. Okay, and also remember that it is equal. Okay, suppose I'm standing here, I'm the first month, then second month, okay, third month. Okay, so you know that based upon the discount factor the value will be reduced. Okay, but here the amount which is was there, it is equal always. Suppose this is x here, this is also x, this will be also x. Okay, so each year you have to give the same amount of money. Okay, how to find it out that how much installment I have to pay, that I will explain. An immediate statement what you're asking, the strategy was using the six equal annual payment of x with a present worth factor zero point 0.9. What should be the x is the annuity due and the ordinary annuity. Okay, just try to find it out with certain logic. Okay, and after that I will give the solution. Just think over it what it is actually asking. Okay, just read the statement. You will not get the actual feel of the question, but just read it out and try to feel that what is actually it is saying. Okay, let me explain. Okay, so this problem is little bit complicated, so I have to explain from the depth. Okay, so here it is not asking in the EMI term. but it is asking in the terms of annual terms. Okay, when you see, just listen here, just listen the problem what is saying. You are having a strategy A requires an immediate investment of 5 lakhs. Okay, and strategy B uses six equal annual payments of X with a present worth factor of zero point 0.9. Okay, what is the value of X? Okay, so when you see the initial investment which was required, it is 5 into 10 to the power 5 when you are not paying the installments. Okay, but what you have done, you have break this amount into the six equal installments. Okay, this was first, second, third, fourth, fifth, and sixth. Okay, so in the six installments. Okay, basically, and this you have given at a zeroth year, and this you have given at a fifth year. Okay, so let me see. Okay, so because when you already know the present value worth, after in the future it will go in on reducing. Okay, so let's consider that. Okay, suppose this is a zeroth year. Okay, and this is the first year, this is the second, this is the third, this is the fourth, and this is the fifth. Okay, when you see in this problem, okay, so suppose I am considering x amount here is the present value. Okay, but when you see here that this value, okay, because I'm considering that x is the equal amount which I have to pay. This is not a present value, it's a equal installment. So I have to pay X amount here also, X amount here also, X amount here also, X here, X here. Okay. So I have what I have done, I have divided a certain value of money into the six consecutive installments, which is the equal amount. Okay. So this also X, this will be also X, this will be X, this will be X, this will be X. Okay, so what amount I have to pay. Okay, so this x, when you see, this is the discounted value. Okay, okay, so when you discount x, then it will become x. Okay, so it means that when you convert reverse, when you wanted to move. Okay, okay, so it will become x multiplied by 1 plus d to the 1 plus d. Getting my point? Because when you moving from the present value to the future value, its value will go on, will reduce. Okay, its present worth will reduce, but when you take the same amount to the present value, its value is higher. Okay, so at a present the value of money will be higher as compared to the future value. Okay, similarly when you take this x here, so this value will become x 1 plus d of square. Getting my point? In case if you have any doubt, just let me know. Okay. This x when you take here, it will, its value is higher. It will be because the present value will be higher. So then when you take this value, this amount here, it will become x 1 plus d to the power 4. And similarly, when you take the last amount, it will be certainly here like this. So it will become x 1 plus d to the power 5. Okay. So at the present worth, you got the all the values of money which is required. Okay. So how much it is required? It's a x of particular value, x 1 plus d, x 1 plus d of square. Okay. X 1 plus d of cube, x 1 plus d to the power 4, x 1 plus d to the power 5. So this is actually the equal installment which you have to pay. Okay, considering the present worth. Okay, so when you wanted that ki what because the what is the total amount which you have to give is this. Okay, Are you getting? So this value, this all value summation will be equal to 5 into 10 into 10 to the power 5. Okay, because this is basically the discounted value which I have to pay. I have to pay in the consecutive years. So this value at a present terms it will become like this. Okay, so when you sum all these values, okay, and equate to what is the 5 into 10 to the power 5, okay, you will get the what is the valuation, what is the equal installments you have to pay. Okay, so when you sum it up it will become like this: 5 into 10 to the power 5 equal to x. Okay, x, when you take the summation, how much it will become? It will become x. Basically when you take the all the terms common it will become x 1 plus d plus 1 plus d of square plus dot 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 1 plus d to the power 5. Okay, so this is the amount which you require to pay. Okay, just put the value of discount, it is already given the point 0.9 here. Okay, and then you have to find out the what is the value of x. Okay, this is the one first part. This is the annuity due. It is called as a annuity due. Okay, but when you see the ordinary annuity, okay, it's a something which you don't have to pay at a zeroth year. Okay, you zeroth at the zeroth year you don't have to pay anything, and in the subsequent year you have to pay. Okay, that means that you have to take the sixth year also into the consideration in this. Okay, similar method x 1 plus d, but this value will not come into the picture and extra term will get added 1 plus d to the power 6. Okay, in the second part similar way you will find it out what is the value of x. Okay, so are you getting my point? Just see once, after that I will explain the further what is actually saying. Okay, so in the subsequent year you just have to find it out the what is the discounted value which is required, and then you will find it out what is the current. Here one I think 1 plus d plus square 1 plus d. uh, okay, okay, that is fine I think. So just remember that I have told what is the annuity due, what is the ordinary annuity. Okay, just remember this. If you are breaking all the equal sum of money into the installment, this is also the way to calculate the EMI also. Okay, there will be interest rate for a equal year. Okay, and that is the same way the EMI will be calculated. Okay, let's move further, try to solve this. Okay, the second part is somebody asking again. So second part is basically the when you have the ordinary annuity. Okay, so let me explain here. Okay, so this you can see. Okay, there is a problem in the solution. So I will update the solution. So here just remember that at the zeroth year you are giving a certain amount. This is x. Okay, but in the ordinary annuity you don't have to give here. Okay, you start your annuity from the first year. Okay, So this is the zero at a present day, and the x amount at a first year, then certain amount x at a second year, then sixth year you have to give the x amount. So it's when you see x, how much its present value x 1 plus d. Okay, then similarly when you do for the other month at the sixth year, it will become x 1 plus d to the power 6. Okay, so it's a 0 plus x 1 plus d to x 1 plus d power 6. Okay, so when you discount it and sum it up, then it will become the ordinary annuity. Okay, because the zeroth amount value, it is not being considered. Okay, so in the ordinary annuity, getting my point? Try to solve this. Let's wait for 10 more seconds. After that, give the solution. Just remember what I have told previously. What is the annuity due? What is the ordinary annuity? Okay, and remember that when the inflation comes, it will come to the both values, not in the one single value. Okay, so inflation, considering inflation also, one amount will be the higher. Okay, let me explain. So we have already know that here ordinary annuity B part will be the correct, because annuity due is basically starting from the zeroth year, but the ordinary annuity will start from the first year. So that's why its value will be higher as compared to the annuity due. Okay, so the option B is actually correct. So that when you see here the statement also, the an ordinary annuity starts later because it's not starting from the zeroth year, it's starting from the first year. So every payment is discounted more heavily. Okay, because its present worth is smaller for the same x, a larger x is needed to match the same present value. Okay, so when you start from the zeroth year, that is x amount in the first part, uh, uh, that is the annuity due, and then you move to the first year, then second and same value. So this also x, this will be also x. So the total amount when you see here, it will become x 1 plus d dot 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 till x plus 1 plus d to the power 5. Okay, but when you see the ordinary annuity, okay, in this terms, so suppose this is x, then again future dot dot dot, here the fifth. Okay, so here when you move further, it will be sixth year. Okay, so first you have to do give the x, here you have to give the 0. So here when you see, it will become x 1 plus d. Okay, then here x 1 plus d square dot 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 x 1 plus d to the power 6. Okay, so when you compare here x divided by 1 plus d here, so because of all the terms here till here, it will be same with this. Okay, only thing which got added up, it's basically x here and x 1 plus d to the power 6 here. Okay, when you compare both, so x 1 plus d to the power 6 is greater than as compared to x. So that's why when you see the ordinary annuity is already higher because it's starting later stage. Okay, let's move further, try to solve this. If you know the concept of levelized cost, I will explain that. This is a similar kind of in cost in the terminology of the when you see what I have to say, uh, equal cost which is be given yearly basis. Okay, try to solve by understanding the statement. I will give the solution after that. Okay, okay. Anyone else? Okay, I will derive the formula also in this. Okay. Anyone else? Just see what the concept I have give. Okay. Okay, let me give the solution. So option B is actually correct. Okay. Levelized cost means what is the meaning of levelized cost? Here when you see, uh, suppose uh, at a zeroth year, okay, certain electricity cost, or you can say energy cost also. So certain X rupees per year it is per kilowatt hour. Okay, or you can say X rupees per unit. Okay, so it is basically the electricity cost. Okay, for the zeroth year. Let's move to the further years. Okay, so now when you see in the move further, what was the first year? Okay, the price, okay, got increased. Okay, when you move to the this year, so okay, so it is basically the X, the inflation. Suppose I'm considering inflation as I. Okay, so it got increased by I and it is constant throughout the year. Okay, so if you see the first year value, due to an inflation, the X plus I, because its value get increased. But also when you see in the discount term, it will also get discounted. Okay, so this value at the first year. When you move further, suppose I move to the second year here. Okay, so when you see the what will be its value, it will again get inflated by the same amount, that is I square, and also get discounted by the 1 plus d, that will become 1 plus d square. Okay, same suppose it went to the nth year. Okay, so I'm considering that inflation cost will be the constant. You can take the variable also, I1, I2, I3. Okay, x nth year 1 plus I to the power n divided by 1 plus d to the power n. Okay, This is the value when you see that ki equal this value at a present stage is the x. Okay, but in the problem in the question what is saying that you have to convert varying yearly cost into the constant annual equivalence of that is called as the levelized cost. How to do that? Okay, let's consider. Okay, let's consider that this is the p amount which was there initially, and this was the p value, this was the p value, this was the p value. Okay, till the nth year the equal amount, the levelized cost of electricity here. Okay, so you can take the levelized cost of energy, levelized cost of charging, levelized cost of discharging, different kinds of for the electric vehicle terms. Okay, so it's a basically levelized cost of electricity. Okay, so when you say that p, it's all equal. Okay, so p is equal to here x 1 plus I 1 plus d. Okay, what is the value of x here? So when you wanted to take here, the x value will be equal to p multiplied by 1 plus d divided by 1 plus I. Okay, so that is the amount here, p 1 plus d divided by 1 plus I. Okay, because when you are taking the value to this place. Okay, because if you're considering p there. Okay, so it will become the present worth will be higher than that. Okay, and inflation got lower than that, that is 1 plus I. Okay, so that's why when you see the value here, so it became the p 1 plus d divided by 1 plus I. Okay, similarly, when you take the other values also, it will become p 1 plus d of a square, 1 plus I of a square. Okay, a similar value p 1 plus d to the power n, 1 plus I to the power n. Okay, when you take the all the values. Okay, okay, so the total amount what was there, it's a p plus p 1 plus d to the power square plus 1 plus I power square plus dot 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 p 1 plus d to the power n, 1 plus I to the power n. Okay, suppose I am taking that key, it is the overall lump sum. Okay, suppose it's a suppose I am taking y. Okay, so what was the initial cost was there at a y value, it will be total cost. Then y, when you take the sum. Okay, just use the geometric progression formula. It's a basically uh, if you're having 1 plus x square, it's basically the a 1 plus rate r to the power n minus 1 divided by 1 plus r minus 1. Okay, so it's a basically a basically it's a p 1 plus d means कि 1 plus d to the power 1 plus I. When you divide it, it is basically the 1 basically 2 to the power n minus 1 divided by 1 plus d 1 plus I minus 1. Okay, so what will be the present worth which was we have found it out? It will be equal to p basically equal to this term. Suppose I am considering this as a theta. Okay, so it will become y multiplied by theta minus 1 divided by theta to the power n minus 1. Okay, so this is the equalized levelized cost of energy throughout. Okay, and this y value will be given. Okay, means ki this is the total amount which is required cost across the 10 year, 15 year, 20 year. So it will be given, and this will be converted into the equal amounts, what is the levelized cost throughout the years. Okay, so this is, remember that ki levelized cost is basically the equal amount which is annual equivalent cost which will you have to give the throughout the year. Okay, let's move further. uh, just see that whether it is correct or not. Worth factor which we have seen, worth factor is basically 1.1 plus t to the power n for a nth year. Option B, I got one answer. Okay, that's correct. That okay, option C is actually correct. Why? Because there is a information which we have already given here. Okay, if you see this formula here, we have not considered the inflation. Okay, so it raises the planning cost, because when you have the present value as x, and with the inflation it will increase to x plus 1 plus I, and also it get discounted by d. Okay, but when you see the x amount, it got inflated if you are not discounting, so it's actually increasing the planning cost. Okay, after suppose I wanted to build a house, present value, so I will require less amount because the inflation is lower, and after means ki certain I'm having the x amount, so after inflation, after first year, all the commodity prices which is required to build that house, suppose you want to that sand are required, or when you see the cement which is required, so all the amount prices will increase in a year. Okay, so the commodity price or the planning cost after a year, it will be more as compared to the present year. Okay, but when you see the, it is not normally included directly in the present worth factor, but we know that ki 1 plus I when you put, it will increase the inflation, the particular amount of present cost. Okay, so what it to be seen that inflation raises cost, that is fine, but it is normally not taken into account directly in the present worth factor. So correct its statement C. It raises the planning cost, but it's not normally included in the directly in the present worth factor. Okay, let's move further. Try to solve this. Okay, let's wait for a few more seconds. Okay, that's correct. The option B is actually correct. Okay, so the planning cost, when you see, it's a basically the C naught value, which is the initial investment, which we have to give, and certain amount which is the operational cost. Okay, suppose I'm taking O as a operational cost. Okay, so this amount you have to understand by certain amount. Okay, suppose I am standing, I wanted to construct a house. Okay, in which initial investment is C naught. Okay, and operational cost, or you can say the recurring cost, is basically O. Okay, so when you stand at a zeroth year, suppose the present year, and this is the first year, and you have a planning of a 3 years, basically that in 3 years you will get your house to be built. Okay, zeroth year, what was the cost? What was the cost associated when you wanted to see what is the operational cost will be required. So at the C naught, this is the present investment I have done at the zeroth year only. Okay, but say certain amount of cost which is the recurring cost is, suppose I wanted to add something, I wanted to decrease something, I will consider that it is a constant. Okay, and this was the O. Okay, operational cost at the first year, you can say the recurring cost, and then second year also and the third year also. Okay, but I wanted to see that okay, what is the total amount I will require here at the zeroth year. Okay, then in that term, suppose the discount rate is D, what will be the total amount? Okay, so it will be basically O 1 plus D. Okay, because this is the O amount which is required at the first year, but at a present its worth will be higher. Okay, plus O1 plus D of square plus O1 plus D for cube. Okay, so this is the total amount which you needed at a present value to say that ki this much amount of total amount which I will require to build that house. Okay, there is a different way to also to understand. Suppose I say that ki here itself, suppose I am saying here itself, I will require C naught plus O amount which is required the operational cost. Okay, but when you wanted to see that key what will be in the first year. Okay, here I am not considering this O which is there at a equal amounts at a different years. I am considering, suppose let take the Q here, Q value. Okay, different. So if you require Q value here. Okay, so what will be the amount? It will be Q divided by 1 plus D. Okay, what will be the second year? Q 1 plus D of square. Okay, Q 1 plus D cube. Okay, so when you see the nature genesis of this statements, Q is the equal value at that year only. Okay, we already know the value which is required at the first year, second year and third year, but in the second say where I am considering the Q amount, it's a basically I am assuming that the Q amount will be required. Okay, at a present I see that Q amount will be required, but in the subsequent year its worth will be lower than that. Okay, maybe I required lower amount in that. Okay, so considering current amount, so this was the correct approach. You already know what will be the operational cost. Considering from the other ends that key, it will always the planning will be the higher amount side. Okay, so the C naught is the initial investment and the O is the require the recurring cost over the years. Okay, let's move further. So the option B is correct. So planning cost is basically two types: initial investment or operational and recurring cost. Try to solve this. Option C. Okay. Check again whether it is correct or not. Okay, I got multiple answer as option C. Okay, so that's option is actually correct. The power and energy loss cost. Okay, why it is there? Okay, when you say that ki this is the variable cost in the distribution planning. Okay, one which we have seen the fixed cost which is required, means ki you cannot move from that, and second is the variable which can vary with the inflation, with the discount or anything. Okay, so this is the variable cost basically. So when you see the annual insurance, okay, annual insurance is basically constant value, okay, which is not going to vary, okay, which is calculated, which we have to give at a end, okay. Or when you miss something happened, then you will get the insurance money out of that. Second is the scheduled inspection. Scheduled inspection is not a variable cost. We know that ki how much inspection cost is required, but when you see the power energy loss cost, it is not actually constant because the loss can will be variable over the years. Okay, so that's why it is not considered as a fixed cost. Recertification fee, we already know the 1,000 rupees will get, the certification will be there, and that kind of fees is not a variable cost. Okay, let's move further. Try to see this. There's a two kind of planning. There is static planning and dynamic planning. So consider this the static planning first. Okay, okay. Option B, option B, option B. Okay, okay. So this is correct. The option B is actually correct. So static planning is means you are planning for a one step planning because the load is not going to increase further in the coming years. Okay, so that kind of saturated planning is there. So this is uh, not considering the expansion of the load growth. Okay, so option B is actually correct. So static planning is basically it is not considering the consider the load growth, but when you see the dynamic planning, the load growth in the existing network and addition of new node, so that the static planning is best described by this. Okay, see this. This I have already explained. So option B is actually correct. That load growth and the possible addition of the new nodes will be considered in the dynamic planning. Okay, let's move further. Try to solve this. Okay, others. Okay, that's correct. The option D is actually correct because we don't want to know that okay, what is the boiler steam pressure will be there. Okay, that is depending upon the load. No, okay, how much load will be there, how much generator have to supply to meet that demand. Okay, but in between to give that power from the generating unit to the distribution network, so you require a number of different equipment in between, power system equipment. That is basically the number of tie lines, how much required to send that power, what is the conductor size of feeder, what is the number and location of that switches. Okay, so that kind of variable will be required in the distribution planning, but boiler steam pressure is not a usual planning variable. Okay, let's move further. Try to solve this. Okay, okay. Anyone else? Okay, that's correct. The option B is actually correct. Why it is there? Because when you see the first statement, it is saying the maximizing the node voltage deviation, but we don't know, or we don't need that. Okay, we need that key we fix voltage at a certain, because if there is a voltage deviation will be there, then the reactive power support will be required. Okay, so that's why we don't require any deviation. Okay, and third C option, when you see maximizing the number of loops, that is false, because we wanted to minimize the loops so that the cost will be minimized. Okay. Third D statement, when you see the minimize the number of substation regardless of demand, that is false, because we are planning for the distribution network. We have to feed the demand, so that's why we cannot minimize the substation number regardless of the demand. That is false. So option B is correct, because it is saying that you have to minimize the installation cost and the power loss. Okay, let's move further. Try to solve this. Okay. 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 That's correct. Basically, option C is actually correct. So it is basically that key equality constant will be set the summation of P, whatever the requirement is there, I is equal to 1 to n from all the generators, suppose the G generating unit, and it should match that J is equal to 1 to m power which is required in the demand side. Okay, DC. So that's why this is the basically called as the total real power, or you can say the equality constant. Okay, you can say that. Sorry, one second. So objective was that to minimize the total installation cost. This was the further. This was the further. Okay. So it will be such that ki equality constant, so total demand plus losses. Oh, sorry, I have losses. I have not considered in this. So you have to consider the losses also. Okay. So this is called as equality constant, and this you have to minimize to reduce the total cost. Okay. So let's move further. Try to solve this. Okay. So the option B, it is radial distribution network. It is required number of energized branches. Okay. It is actually correct. Okay. So radial distribution network with the 48 buses, the required number of energized branches is actually 47. Option B is actually correct. Why? because the number of branches for a connected radial network, the number of branches will be number of buses minus 1. Okay, that we have seen also in the network analysis also. The number of branches will be required is equal to n minus 1, number of nodes minus 1. Okay, so the number of buses, when you see, b is equal to n minus 1. Okay, try to solve this. Okay, option b, option b. Okay, so the option B is actually correct because radiality constant is not for the closed loop operation. So this is for the radial distribution network. Okay, so the option B is actually correct. Okay, so the radial distribution network must not form loops. Okay, so that's why it's a false. Try to see this. Okay, okay, I got few answers. Okay, so the option C is actually correct. Okay, they can obtain Pareto type solutions and handle non-linear and non-convex problem. Let me explain. So when you see the population-based algorithms, okay, okay, so there when you see they perform multi-operate point search because they try to find out the multiple points where to feed that load and try to minimize that and operate the obtain the Pareto type simulation in the single run. Okay, and they also handle the non-linear, non-convex or non-differential problems effectively. Okay, so not overburdening the system by giving the differential problems. Okay, so the option C is actually correct. Try to solve this.
आदि दीदी इधर देखिएगा.
Okay, option B, I got one answer. Phew, the convergence is not always guaranteed. Okay, so the option B is actually correct. So drawback of a evolutionary algorithms is that the convergence is not always guaranteed. So option B is actually correct. Okay, so that's why we need a linear discrete linear kind of system. So that's why try to solve this. Okay, option C, option C, option C. So the option C is actually correct because the PSO algorithm, they are under the population based algorithm. Okay, so that is actually a particular SOM optimization. Okay, let's move further. So according the further slide, the PSO update particle mainly using. So it is basically the update the try to learn from the previous statements or previous process. So that's why um, how the iteration actually happens. Okay, okay. So the option B is actually correct in this because in PSO the particle update is based on the previous velocity or any kind of parameter which is required. Okay, and the particle's own base position and the population global base. Okay, let's move further. Try to solve this. Okay, its option B is actually correct. It has easy implementation, often fewer function evolution. So that's why the B is correct. Okay, try to solve this. In this objective function, you have to find it out how many number of decision variables are there. Okay, this is the one of the problem in the I think assignment also. Okay, try to solve this. I will explain. Okay. Option C, option C, option C. Okay. This option C is correct because we already know whose value we cannot find it out or the value is not given. So they are considered as the variable. This is x1, x2, x3, x4. They are actually the variables. Okay. So the option C is actually correct. Let's move to the last problem of this session. You have to tell me the what is the advantage of the proposed cost-based decoding scheme in the planning algorithm. Okay, C and B. Okay, C. Mm, again, think. So in this option B is actually correct because it's always create a connected radial network. Okay, so that's why this bias decoding scheme is mostly having advantages because if you consider the mesh network, so the disadvantage of computation becomes lengthy. Okay, that's why the radial network usually it creates whatever the network you give, it converts into the radial network and then it find it out the and do the computation on the basis of that. Okay, so that's all for today's tutorial session. So we have seen few of the problems related to the discount rate and also present value, future value, and converting the amounts into the equal installment. How to solve that and some of the few terminology based on the different optimizations. Okay, so that's all for today's session. If you have any doubt, let me know. Otherwise, I will end the session here. Okay, then, thank you so much for joining. So, if you have any doubt, we will clear it out in the next tutorial session. Just see the problems which I have solved and try to solve the assignment problem, and we will discuss in the next tutorial session. Okay, thank you so much for joining.